We'll go over some of the challenges of cloud-native application development today. Give an introduction to some of the concepts of Radius. We'll talk about applications and environments. We get a demo from Ryan that'll make that a little bit more concrete, and then wrap it up. So I'll start with some context about the Azure Incubations team, which is the org that's working on Radius. The team's been involved with the CNCF quite busily for a few years. Kata was the first project out of the team. It graduated in August. It's focused on scaling Kubernetes clusters, auto-scaling. Dapper, which you might be familiar with, is focused on making it easier for cloud-native developers to write code that runs across clouds, is portable, and encapsulates a lot of best practices. That is incubating as of this month. Copacetic, more recent project, just got accepted as a sandbox project in September, and then finally Radius, which we submitted for consideration as a sandbox project late in October. Hence the presentations and discussions here. And thanks as always to the CNCF for a great partnership. Specifically with respect to Radius, we've talked over 70 customers over the last year or so, and we focused on a number of key challenges that customers consistently tell us about. One is, as you guys know, cloud-native application architecture is increasingly complex, right? There's still a lot of sort of 2- and 3-tier web apps out there, but increasingly you see much more complex microservice applications that are hard to design well, to implement effectively, and certainly to operate effectively. They're distributed systems, so by their nature, they tend to fail sometimes in pretty complex, unexpected, and nuanced ways, so they're hard to troubleshoot. That's all compounded by the fact that every customer we talk to, almost without exception, has to deploy some of their software on-premise, some on AWS, Azure, GCP, a real mix. And all those platforms obviously have a different dev and ops experience in terms of APIs, in terms of GUI and a portal, and in terms of tools. Then lastly, the operations side of these application teams, the folks that make the decisions about infrastructure, which could be a DevOps team, a cloud center of excellence, a platform engineering team, they really struggle to enforce best practices that around security, ops, and cost, while still enabling their developers to innovate really quickly. So those are areas we focused on. Now, folks obviously at this event are very familiar with the rise of Kubernetes as essentially the standard for cloud-native infrastructure platform. And Kubernetes, we see our customers, Microsoft, gravitating to Kubernetes because it allows customers to deploy their applications wherever they need to based on their requirements, whether that's on-premise or their hyperscaler of choice, and the credibility that comes with such a vibrant open source and mature open source ecosystem. And while that's been a big game changer, obviously Kubernetes doesn't address all the problems of end users in this space. We have seen this trend toward having to grapple with lots of different technologies to kind of complete the rest of the story around defining and deploying cloud-native applications. So those applications end up including and depending on a lot of technology on Kubernetes. So you may have depends on managed cloud services like Azure Blob Storage or AWS S3, maybe on some open source services like Redis Cache running on-prem or in the cloud, and then on and on, sort of API gateways, observability systems, key value stores. There are lots and lots of pieces that make up a cloud-native application, and we see customers bringing together sort of a mishmash of technologies to address all those pieces and parts. So you might see on the infrastructure side, Terraform scripts, Bash scripts, and PowerShell in a lot of cases, Helm charts to package up an application. Those things in aggregate end up with this kind of deployment forming what's often a pretty kludgy and sometimes very brittle kind of solution for deployment. Then after all the investment in those technologies, the output of a deployment like that ends up being a very simplistic, flat list of resources. You would see that on AWS, you see it at the Azure portal, and there's a real challenge with this kind of one-dimensional view the representation of an application, you really don't see your app, right? You see a bunch of pieces and parts, you see a bunch of deployed services. But if your app, say, includes a front end, a Redis cache, a back end, and a SQL database, like where's the front end in this view? Where's that Redis cache in this view? So you don't see those dependencies and relationships, which makes it super hard for developers and operators to collaborate to keep a service running because they don't even have a shared view of what's deployed in production. So this is the general problem space that we focused on for Radius. And there's a number of areas that we've kind of prioritized as the project has evolved. One is making sure that we make it easier for developers and operators to collaborate as part of an applications team. So we want the developer to be able to focus on their application exclusively, not dig into a lot of nuances around infrastructure, and operators to focus on defining and configuring the environments where those applications are going to run. We enable those capabilities for operators via a feature that we call recipes that I'll talk more in a bit, and that Ryan will demo. Recipes allow an operator to encapsulate org best practices and to give developers kind of a self-serve experience with access to the resources that their applications need, all in a way that follows org best practices by default. Thirdly, one of the outputs of a Radius deployment is an application graph. That application graph essentially defines the topology, represents the topology of the application. So what is that front-end container? Where's the Redis cache? How's the back-end container connected? So we bring teams to a point where they do have that shared view of application architecture so they can more effectively collaborate in supporting that application. And then lastly, Radius was designed from day one to be cloud neutral. So we've really taken seriously this issue, this requirement for customers to deploy to whatever cloud platform or on-prem environment that meets their business and technical requirements. So I'll quickly go through what some of that means in practice, and then Ryan will demo some of the concepts to kind of anchor it in the experience that developers and operators have. So, like, what does it mean in the context of Radius for a developer to focus on the definition of their application? They express their application in a way and in terms that are meaningful to the developer. So they've got an internet gateway, define a front-end container, the cache for that container, the back-end that's connected to that container, their database for persistent storage. They focus entirely on that piece of application design. And at the same time, their operations counterpart focuses on defining and configuring the environment where that application is ultimately going to deploy. Now, in this example, the environment is a local development environment. The application, so recipes allow the application components to bind to the infrastructure dependencies that exist in that environment. Because it's a local dev environment, we've got a local Kubernetes cluster. We've got a Redis and SQL or Mongo running in containers locally on the dev box. So that dev has what they need to develop and test locally. And then once they're ready to deploy to the cloud, say if they want to move to Azure for either test or production, that app can be bound dynamically to an Azure environment without any change to the application code. So the recipes in the Azure environment bind that application to Azure native resources, including Azure Cache for Redis, Azure Cosmos DB with the deployment happening to Azure's Kubernetes service. All that binding happening with no change to the application code. Just as readily, the application can be bound to an environment that's native to AWS, using MemoryDB, DocumentDB, and Elastic Kubernetes service with no change to the application. So the application in this kind of scenario is being treated as an immutable resource that can be deployed to whatever environment meets the business and technical requirements of the team in question. So that gives a sense of how we've tackled addressing some of those challenges I discussed at the outset, delivering features like recipes and the application graph to make it easier for teams to work together, deploying across clouds, and enforcing best practices by default. So that's a lot of conceptual sort of content. So
all right. Thanks, Jonathan, very much for the intro. Let's all give Jonathan a little hand. I know it's really loud in here, but he works really hard. We love this guy. So thanks, everybody. I'm going to do a quick demo for you of Radius, and then I'll talk a little bit more about the project and kind of where we're going with it. So I'm going to start from the operator point of view. As part of the design phase of Radius, we went and had conversations with about 60 to 70 cloud customers of Azure, of AWS, of other clouds, and talked to mostly their platform engineering kind of IT operations teams. And what we learned from those conversations is, first of all, that platform engineering is about treating the developer experience inside the organization as a product and improving that and making life better for developers inside the organization. And so what that means is we want to give developers self-serve ways to get their applications into production, to get set up with the things they need, and try to eliminate manual processes and manual workflows, because we all know this can fail due to humans, or it could be slow and reduce your efficiency. The second thing we learned, almost all of them were on at least 2 clouds. And so being a platform engineer or an IT ops department person in one of these clouds, usually, or one of these companies, I should say, usually means that you need to support multiple clouds. So it's pretty rare that somebody's going to take a single application and deploy to, a bunch of different clouds. Some people have to do that, but it's rare. But if you're the platform and the ops team, you really need to support different clouds that your developers are using or that your applications are already on. And so wouldn't it be great if the tools that you're using, first of all, if they were open source, and second of all, if they work consistently across all the places where you need to operate and deploy applications. And this is part of the inspiration behind features like Radius, recipes, and environments. So in this demo, I'm going to kind of put on my operations platform engineering hat. I'm going to talk a little bit about the configuration of environments and the configuration of recipes. And then I'm going to switch to the developer point of view. I'm going to take an application that I've already written. I'm going to deploy it to a local testing environment on my machine. And then I'm going to deploy it to 2 different clouds. And then we'll kind of look at what happened and talk about it and understand, what Radius is doing behind the scenes. So if I put on my platform engineering hat, well, there's probably a number of technologies in the organization that we support. Maybe we support Postgres and Redis and Mongo. And so my job as an engineer is to define, a platform engineer, is to define environments and templates that can be used to go to those different environments in supported, secure, and cost-efficient configurations. So to that effect, let me introduce you to a recipe. And this is a recipe for Azure. It's going to create a Redis cache. This will run on demand when developers deploy an application. It's written in the Bicep infrastructure as code language. You may or may not have seen Bicep before, but if you've seen Terraform, you can think of this as kind of conceptually compatible to Bicep, to Terraform. And I like starting with this one because it's a pretty simple one. We think Bicep is a pretty simple and productive language. And I'll show you kind of the 3 things that need to happen in a recipe. The third thing that I'm going to do is I'm going to return some data to Radius from the template. This powers the experience of how the application gets connected to this Redis cache. So I'm essentially providing the configuration for how applications are going to communicate with this resource when they get deployed. Now, the reason why we care about recipes and the reason why we have platform engineers is to enable a separation of concerns between application developers who are focused on their business use cases and their code and their logic, and platform engineers, security operations folks, and other operations roles that care deeply and need to understand how the cloud is being configured. If I were a developer, I might be tempted to do something like this and set this to false, right? I'll enable non-SSL access to my Redis cache, which could be really bad. Or maybe I decide that like, hey, TLS 1.0 just sounds really good to me. I like a nice round number, right? But that would be really bad. And obviously these are jokes. But as we've talked to cloud customers that have given their app devs keys to the kingdom, a lot of the time this is what happens, right? Developers don't really know, they're not aware, it's not their job. And so they might make mistakes or configure things in a way that's really expensive, not secure, not very usable, redundant, etc. That's why we created concepts like recipes. So let me show you another recipe, because I mentioned that we're going to go to both Azure and AWS. And this is a recipe for AWS. And yes, I work for Microsoft, and I'm here at the Microsoft booth, and I'm going to do an AWS demo for you today. I hope that that's kind of exciting. When we talk to a lot of these folks, a lot of them are using Terraform, and a lot of them have big investments in existing Terraform code that they want to keep using. And nobody wants to start over. In terms of how Radius thinks about recipes and the technologies that we're trying to enable, we want to be very unopinionated about what you can do, what kind of technologies you can use. And so as we heard that, we made sure to enable Terraform as well. So this is a Terraform recipe for Redis. It's going to create an AWS MemoryDB on AWS. And what I've done here is I've taken a module from the Terraform public module gallery, and I've kind of wrapped it into a recipe. And again, same as our bicep recipe. I started there because it's simpler. But what we're going to do here is we're going to get some data from Radius. You can pass in this information. We're going to create the resources we need to create using this module. And then I'm going to return some data to Radius about how the application can connect to this cloud resource. It's the same kind of pattern. And so you can think of this as an example of what it's like to take your existing infrastructure as code and make it a recipe so that it can be used on demand. So the next kind of thing that I would do as an operator, and I'm not going to show this in the demo, but I want you to kind of think about it, is I would take these recipes and I would configure environments where apps are going to be deployed, and I would register these recipes in the environments. The important thing about that is that the person who gets to set up the environment gets to control what kind of cloud resources can be created by developers and how those resources are configured. It's really important that we maintain this separation of be able to kind of escalate privilege and create things that they're not supposed to create or create things in the wrong configuration. So we're able to set some guardrails here. Developers get a self-serve experience, but the needs of the whole organization are being met by this. So if you kind of pretend that I did that, I'm going to shift gears here and I'm going to put on my developer hat for a second. What I've got in this repo is I've got a to-do application that I've described with a Helm chart. And I'm starting with an existing application because Radius doesn't change that much about how you build applications, how you deploy them, how you set up your CI/CD pipelines, and so on. So there's no SDK or libraries. There's no custom format you have to learn. If you're working with containers today, you don't have to change how you're doing that. You can publish those containers like you're doing today. You could use whatever pipeline or GitOps you're using today. We don't want you to have to change any of those kinds of things. That's why I'm starting with an existing app. And this one is described using Helm. It's kind of an existing Kubernetes application. There's some other ways to interact with Radius. We're kind of doing our own thing there as well. But for this audience, I'm going to focus on the Helm example. And so as a developer, I've learned about Radius. I've learned that Radius is enabled in my environments. I can use Redis, which is something I need in this to-do application that I'm building. And I want to figure out how I can add Redis to this application and kind of onboard with Radius really easily. So to that effect, we're going to start modifying this, and then we're going to start running it in different places. So I've got my Helm chart here, and down at the bottom, commented out, I've got a CRD that I can... it's always weird to do key bindings when I'm standing up. I don't know if anybody else has that trouble. And so what I've got here is I've got a CRD, so you can use Kubernetes to talk to Radius if you want to. And what I'm saying is I want to create a Redis cache. This is basically telling Radius in kind of our registry of types, Redis cache is the thing that I want. And you'll notice what's not here, right? I didn't say what cloud service to create. I didn't say what SKU I want, what network rules to create, what level of access I need, what username it is. I don't have to say very much. I don't have to think about very much. And so by keeping the infrastructure definition outside of the application, I get an on-demand experience, but I don't have to hard code my application to the specific infrastructure or specific infrastructure configuration that I'm using today. So if I took this Helm chart and deployed it to a Radius-enabled cluster, I would get a Redis cache if the environment supports it. The other thing that I want to do here, because we've got our container and we've got our Redis cache, I need to say something about how these things are going to communicate with each other. I need to know how to connect to that Redis cache from the app, and so we're going to solve that next. The way that I can do that is by adding annotations to my existing Kubernetes manifests. So I'll say radapp.io enabled true. This step is kind of important because if I don't tell Radius to process this deployment, we're going to leave it alone. So when you add Radius to a cluster or install Radius, we don't start doing things, just willy-nilly. You have to tell us where you want us to start doing things. And so by enabling this, I'm going to allow Radius to treat it as an application inside Radius. The second thing that I'm going to do is declare a connection. So radapp.io/connection. I'm going to give that connection a name. The name is going to be Redis in this case. Connections are named because you can have as many as you want. And we use that name to generate settings for you. And then I'm going to say that connection goes to DB, which is this CRD recipe that I defined down here. So I'm saying that this Kubernetes deployment is going to be connected to that recipe that's going to create a Redis cache. And the thing that this connections do, it's something that we want to feel a little bit magical and a little bit special in Radius. The kinds of things that this will do are like, it will inject environment variables and settings into the application on your behalf. So the information that you need to connect. For a Redis cache, that could be like a URL, username, password, hostname, whether or not TLS is enabled for it, and so on. So you can think about that as kind of injecting settings. If you have existing conventions and settings that you use, like maybe you have your own environment variables that you already read from, we've got good ways to do that too. Since it's my demo and I built it with Radius in mind, I don't have to do this. The other thing that this does, and Jonathan mentioned the application graph earlier, is declaring this connection is going to add to the application graph. So we'll be able to look at what infrastructure was created as part of this Redis cache, and then also things like the topology, the relationships, the patterns of communication in the app to understand how these things are connected. And I know you've all probably seen systems like the application map in Azure that are generated from telemetry data. We're capturing the similar kind of information at deployment time, so we're able to help you reason about the architecture of your application without relying on telemetry or before you've enabled telemetry for everything. So if you ever had this problem of like, well, I want to visualize my application, but I don't have telemetry everywhere, we're trying to help make that better. We also understand kind of deeply what the underlying infrastructure is, which should help. So with that done, I'm kind of ready to deploy this. And let me walk you through how I do that just on a testing cluster as part of my local workstation. So the first thing that I would do, I've already got a Kubernetes cluster. This command, a K3D cluster, it's just running inside this code space. There's no trickery. I run rad-init on it. And so what rad-init will do is it's going to create an environment. If you just run rad-init with no arguments, what it's going to do is some recipes to get started. And so that includes a recipe for Redis. It includes recipes for Dapper, which is another project that we helped build in the Azure office of the CTO. It's going to include MongoDB and kind of a growing set of common self-hostable technologies that are very developer-friendly. So we want you to be able to get started really easily without having to go learn infrastructure as code if you're a developer. The other thing that that's going to do is set up a default environment for me for testing and kind of configure my local configuration to point to that. So when I'm ready to deploy this, this is actually just a normal Helm deployment, and you'll see the commands that I'm running as part of this. I run a script so that I don't have to remember what to type in, but this is just a normal Helm deployment. You can see that it created the app. We can use kubectl to interact with this. We also have ways to do this through the Radius CLI, but as a developer, I don't really like to learn new things all the time, so I'm just going to use kubectl. I can say get all, and I'm going to do that. This is kind of fighting me here, sorry. I'm going to do that in the Helm demo namespace, which is where I put this stuff. And so you can see that a bunch of stuff happened, right? So we've got down here, I'll kind of walk you through this. It's a lot of output. Then we've got the recipe. It's of type Redis cache, and it's ready. Here we can see some web app pods, and we kind of recycled something there. And then you can see some other Kubernetes resources here that look like they're Redis. And so you can probably guess what that recipe did. the recipes that come with local dev, just run these technologies in the cluster on the compute that you've already paid for. Again, we're trying to help you get started and do testing with these kinds of things. And when we go to the cloud, you're going to see something pretty different because we're going to use the recipes that I showed you before. So let's kind of fast forward a little bit. I work on my application, I tinker with things a little bit, I'm kind of happy with how things work, and I'm ready to go to the cloud. I can go find those environments and bring them into my local config, the environments that we talked about before when I had my platform engineering hat on. And so now I'm going to do the same thing, and I'm going to deploy this application to 2 different clouds. So I'm going to run the same command. I'm just going to run a Helm deploy. And the thing that I'm doing here is I'm just using a different Kubernetes context. So I'm going to deploy to this prod AWS environment. Now this is an EKS cluster that I set up earlier, and it's got the recipes that I showed you earlier for creating MemoryDB on that cluster or in that AWS environment. I will point out revision 4, I did cheat. It's not very exciting to watch a demo where resources just create in the AWS console. So I did cheat and I did pre-deploy this, but trust me that this really was really done with Radius. Otherwise, it'd be a very slow, boring demo. And so that worked. Let's do the same on Azure. And again, I'm just pointing to a different Kubernetes context here, and I'm just running a Helm deploy like I could do before Radius came out. And through the magic of CRDs and orchestrators, we're going to take the same application and deploy it to both clouds. Now, you may not be convinced that anything really that exciting happened when I deployed these applications. So let me kind of walk you through that, and we'll look at some of the output and kind of what happened when I deployed the application. First, I'm going to show you what does this application actually look like and prove that it worked in my local dev environment, and then we'll look at the cloud resource that got created. So if I jump here, I can do a kubectl port forward. Do I not have this? I do not have this in my history. This is going to be exciting. All right, so kubectl port forward. It's in the Helm demo namespace, and it's going to be the, what did I call this? I call this web app. I called this web app. Sorry, I'm used to having this in my command history when I do the demo. So we've got pod here for localhost. One of the cool things that code spaces will do is if you port forward inside of a code space, it's going to just pop the browser for you. So just a couple things to show you. We declared that connection to Redis. You can see environment variables that were populated here. This is just an app we use to talk about Radius. It's not anything fancy, but just prove to you that we understood the connection and we injected those settings for you. If I come over to the actual to-do functionality, I can say I'm going to demo this at the Azure booth and add that. And you can see that that went to the database and we were able to save it, so that worked. So we're able to deploy the application. We're able to think about that connection. We've really got things working here. Let's reason about what happened when we took this to the cloud. And I can do that by using the Radius CLI to output the application graph. That's that kind of picture of the application that we developed as we deployed it and as we manage this infrastructure for you. And we don't have a real visualization of this yet. We're kind of working on that, but I can show you a text mode version of it, which I'm going to bring up right now. And this should be in my command history. So rad app graph. I'm going to do this for AWS first, and then we'll look at the picture for Azure. And this is a little bit complicated, so don't worry, I'm going to talk you through it. So our application was called Helm Demo. You can see that we've got our web app container. You can see that we've got our Redis cache DB. You can see that we understood the connection between those two, so the web app talks to the database. If we go down to the database, we can see that the web app is talked to, or the database is talked to from the web app. And then the thing that's going on with this resources section is you can kind of think about what resources is Radius managing? So what resources did Radius have? Well, we understood that deployment that you annotated, the one that I wrote as part of my application. For the cloud infrastructure for this MemoryDB or for this Redis cache, you can see that we got an AWS MemoryDB, a cluster and a subnet group. And those were created on demand by the recipe that I showed you earlier. Radius understands the complete picture of this, so that when you need to troubleshoot something or when you need to work with ops folks on your team that don't understand the architecture of the app, we can all drill down from here's what the app looks like to here's the actual infrastructure that it's running on. I'll do the same thing now, but for Azure. And so we're going to see the same picture for Azure, but maybe a little bit different. And so you can see that we've got our container here that kind of looks the same. We've got our database here, which is a Redis cache. We've got the same connection. And you can see that the infrastructure that we provisioned with that recipe is an Azure Redis cache. So we're running Redis on Azure instead, and that was all managed by recipes. So to kind of wrap up what we saw, as an ops person in the open source community, I can curate those and configure the environments that developers get to deploy applications into. Developers get to use the recipes that I provided, and they don't get to color outside of the lines. As a developer, I get kind of a simplified interface to think about the cloud, right? Rather than thinking about what SKU I need and what network rules I need, I just say what I want to be part of my application and work that Radius and my platform engineering team made it happen. Then I'm able to easily take that application, get up and running in a dev environment to test it out. And when I'm ready to go to the cloud, I can go to any of the clouds that my organization supports. So that's the end of the demo. If you want to learn more about Radius, thank you. If you want to learn more about Radius, we'd love to come chat with you. It's pretty early for Radius. And so we're in a stage right now where we just open sourced the project. We just released it to open source like a week ago. And we feel like Radius is still pretty new. Probably doesn't need in production, just being honest. And so we're kind of at this stage right now where we'd really like feedback about what people like to see. Do you like the strategy? Do you like the vision? Is it aligned with how you're trying to do platform engineering, how you think about application management? Because we're sure that we haven't got everything right in Radius, and we'd love to hear from you. And so Jonathan's going to have some links and kind of wrap us up.
Back up on that.
Jonathan does not know how to operate this computer.
So thanks, Ryan. Awesome demo as always. So a few resources. We announced Radius on October 23rd, and that's when we opened up the documentation. So the website link with docs is listed here. We're already getting great activity, about over 20,000 hits on the doc site. Through the GitHub organization, we're getting PRs and issues from the community across the repos, which has been awesome. So please join us there. Lots of engagement on Discord as well. That's been a great support channel for us. So feel free to hit these links. Join us on Discord, check things out, give us any feedback you have, and that would be awesome. One more slide forward.
Yep, and this is the last call for raffle tickets. So if you'd like to join the raffle and you haven't received a ticket, just stick your hand up and she'll be around to deliver. I see that Archer needs one. And come stick those in, because we're going to draw when this is done.
And we've got stickers up here as well. And then come on and ask questions if you guys want to.
Yeah.
Would love to talk more about Radius. Thanks for the time, everybody.
Thank you.
Great job, man.
Thanks.